Myself Rima Rawat from LG Institute of Engineering and Technology. In today's session, we are going to continue the unit filter design technique. In this unit, today's topics are bilinear transformation method and approximation by derivatives for designing of IIR filters. Also, we will see the FIR filter designing methods. So let's start with that. So, as we have seen in the previous session, there are three methods of designing IIR filters. First one is impulse invariance method, second one is bilinear transformation method, and the third one is approximation by derivatives. In the previous session, we have seen few examples based on impulse invariance method. Now, let's start with the second method, that is bilinear transformation method. So here in bilinear transformation method, all you need to substitute S with 2 by Ts into Z minus 1 upon Z plus 1. That means the data given to us, wherever S is there, you need to substitute it with 2 by Ts into Z minus 1 upon Z plus 1 term, where Ts stands for time period or symbol duration. Let us see the example for this. Here the data is given to us is the transfer function of analog filter is h of s, that is equals to 3 upon s plus 2 into s plus 3 with Ts equals to 0.1 second. Design the digital IIR filter using BLT, that is bilinear transformation method. Here s equals to 2 upon 0.1 into z minus 1 upon z plus 1 is there. So it will become 20 into z minus 1 upon z plus 1. We know that h of s for us is 3 upon s plus 2 into s plus 3, where s is to be substituted by 2 by ts into z minus 1 upon z plus 1. So h of z, that is equals to 3 upon 20 into z minus 1 upon z plus 1 plus this 2 term as it is, that means here it will become plus 2 into 20 into z minus 1 upon z plus 1 plus 3, that means this 3 term. Okay. Now further we can give simplification for this, that will become h of z, that is equals to 3 into z plus 1 into z plus 1 upon 20z minus 20 plus 2z plus 2 into 20z minus 20 plus 3z plus 3. This will become z plus 1 whole square into 3 divided by 22z minus 18 and 23z minus 17, hereby simplifying these two terms. Now, if we simplify this term, it will become 3 into z square plus 2z plus 1 divided by 506z square minus 788z plus 306 by multiplying and opening this bracket. So the final answer over here will become h of z, that is equals to z square plus 2z plus 1 divided by 168.67z square minus 262.67z plus 102. So this is the final answer of h of z, that means the function of a filter using this BLT method. Next method is approximation by derivatives. The transfer function of digital filter is obtained here in this method by putting s equals to 1 minus z inverse divided by t. In the previous case it was 2 by ts into z minus 1 upon z plus 1. Here it is 1 minus z inverse by t, where t is the time period. In the equation we will place this to obtain h of z. So h of z will become ha of s, where s equals to 1 minus z inverse by t. So by simply placing this, we can obtain the digital filter function. This is the method of approximation by derivatives. Next is the designing of FIR filters. Now designing of FIR filters is called as the windowing techniques. There are various windowing techniques available. The first one over here is the rectangular windowing method. Second one is Hamming window method. Third one is Henning window. Fourth one is triangular window. Fifth one is Blackman window. And the sixth one is Kaiser window. These are the different windowing techniques or methods for designing FIR filters. Now, this is the table which indicates the functions for each windowing technique, using which the transfer function is obtained for FIR filters. So for the first one, rectangular window, the windowing function is to be denoted as WR of n, which stands for rectangular window function. That is equals to 1 for the instance n equals to 0 to m minus 1 and equals to 0 for other intervals. Second is the Hamming window. The Hamming window is to be denoted as WHM of n, where HM stands for Hamming window and W stands for windowing method for n discrete instances. The function over here is 0.54 plus 0.46 into cos 2 pi n upon m minus 1 for the instances n less than q. It is 0 elsewhere the regions. Next is the Hamming window. The function for Hamming window is WHN, where HN stands for Hamming window. That is equals to 1 by 2 into cos 2 pi n upon m minus 1, where n indicates the number of instances for the given data. Next is triangular window. It is denoted as WT of n. That is equals to 1 minus 2 into modulo n divided by 2 into mod n divided by m minus 1 in the interval mod n less than m minus 1. Next is the Blackman window, whose function is WB of n, that is equals to 0.42 plus 0.5 cos 2 pi n upon m minus 1 plus 0.08 cos 4 pi n upon m minus 1. Next is the Kaiser window. It is denoted as WK of n, that is equals to IO beta upon IO alpha for n less or equals to q, and it is 0 elsewhere. So these are the functions for different windowing methods, and it is used directly to obtain the function or transfer function for that FIR window. You need to remember all of this for windowing techniques. Here the designing of filters for IIR and FIR is completed, and I hope that these methods of this unit are clear to you now.
Okay, so this is the formula table. Now let us consider one example so that the idea will be more clear. So let us see the example data given to us, which is the desired frequency response HD of omega for the low pass filter FIR is given by HD of omega, that is equals to e raised to minus j omega m minus 1 by 2 for the interval omega less than omega c, where omega c is our cutoff frequency, and it is 0 otherwise. That means outside this interval the value of this function is 0. So this is the data given to us, and we need to design the low pass filter using the rectangular window. Now how we can do this? So over here m equals to 7, that will be given to us. So using this given function, we can take HD of omega, that is equals to e raised to minus 3 j omega, because we put over here m equals to 7, that will be 7 minus 1 6 by 2, that will become e raised to minus 3 j omega in the interval omega less than omega c, and it is 0 otherwise. Now in the data, assume that we have taken the values of omega c and m equals to 7, and in the data, that means in the exams, this data will be given to you already. That means here m equals to 7 and omega c, that is equals to 1 radian per second, that will be given in the data. Okay, so we have taken these two values over here. Now what we need to find is, we need to find HD of n, and whose formula is 1 by 2 pi integration in the interval minus omega c to omega c HD of omega into e raised to j omega n into d omega. This is the formula which we are going to use for any of the rectangular windowing function or any of the other windowing function, whether it may be Hamming window or Henning window or such windows. Now we have taken here cutoff frequency omega c equals to 1. Let us place this in the above equation. So it will become hd of n, that is equals to 1 by 2 pi integration in the interval minus 1 to 1. Here we have the function hd of omega, that is e raised to minus 3j omega. So here it will become e raised to minus 3j omega into e raised to j omega and d omega. So the next step will become hd of n, that is equals to 1 by 2 pi integration in the interval minus 1 to 1. E raised to j omega is common, so in the bracket we have the term n minus 3 into d omega. The integration of this term will become e raised to j omega n minus 3 divided by j into n minus 3 with the limit minus 1 to 1. By placing the limit values upper and lower limit, we will have the equation 1 by 2 pi in the bracket e raised to plus j into n minus 3 minus e raised to minus j n minus 3 upon j into n minus 3. Now we compare this with our standard trigonometric formula. We know that sine theta equals to e raised to j theta minus e raised to minus j theta by 2j. So if we compare this equation with the given one, it will become sine n minus 3 upon pi n minus 3 for n does not equals to 3. Because if we take n equals to 3, this term denominator will become 0. So we need to find the different condition for that. So for n equals to 3, we will take hd of n, that is equals to 1 by 2 pi integration in the interval minus 1 to 1 e raised to 0 into d omega. The value of e raised to 0 is 1. So that will become 1 by 2 pi. The limitation will be 1 minus minus 1. So here we are left with the value 1 by pi. So if we look at this over here, then we can say that we have two values. That means for the conditions n does not equals to 3 and for the condition n equals to 3. So the function for us will become hd of n, that is equals to sine n minus 3 upon pi n minus 3 for n does not equals to 3, and for n equals to 3 the function we have obtained is 1 by pi. Now here we have rectangular window, and as we have seen in the previous table, the function of rectangular window is what? Wr of n, that is equals to 1 in the interval 0 to m minus 1. That is, according to the standard formula, it is 0 to m minus 1, and we have taken m equals to 7 over here. So we'll have the range n equals to 0 to 6. And the value of this rectangular window function is 0 outside this range. Now what we have is, we have the equation h of n, that is equals to hd of n into wr of n. Now we have obtained wr of n already, that is this, and hd of n for this cases, that is this. Now we are going to make the table for this starting from the values 0 to 6, because we have total 7 values, that is 7. So starting from 0 to 6, we will obtain all the values of h of n. So we can take the values of n from 0 to 6 and we can place it over here. Now we know that we have used rectangular window function. So for that, the multiplication will be 1 only. So we can directly write that hd of n, that is equals to h of n. So when n equals to 0, we'll have hd of 0, that is same as h of 0, which is sine minus 3 by 3 pi, whose value will be 0.015. Same way, by taking n equals to 1, we'll obtain hd of 1, that will be same to that of h of 1, whose function is sine minus 2 divided by minus 2 pi, that is equals to 0.145. Next value of n we are taking 2. So for that, hd of 2, that is equals to h of 2, that will become sine minus 1 upon pi minus pi, the value of which will be 0.268. Next value of n is 3. So for that, we already know that we have taken the case n equals to 3, for which we have obtained the value 1 by pi. So that value will be 0.318. Same way, for n equals to 4, we will take value hd of 4, that is equals to h of 4. That will become sine 1 by pi, the value will be 0.268. Same way, we are going to calculate the value hd of 5, hd of 6. We will obtain 0.145, 0.0149. Now you can observe one thing, that above these values and below these values are similar. So you can notice this down. So for higher values of m, if you can find out this 3 to 4 values, the below values you can duplicate in this order. Okay. So this is how you can solve the examples of the windowing according to the function given to us. Here rectangular window is used. You can use Hamming window, Hanning window or such Kaiser windows likewise according to the data given to us. Okay.
These are the references you can refer through. This is the book which can be referred by you for all the detailed descriptions. Thank you. Thank you for listening.